24,000 feet above Hamburg, at 3 minutes to 1 in the morning, on July 25, 1943, a young RAF wireless operator named Ted Church checks his stopwatch. It is the only piece of equipment standing between his Lancaster and the German night fighters waiting somewhere in the dark below. Every 60 seconds, on his mark, the bomb aimer pushes a bundle of what looks like ordinary tinfoil down the flare chute. It catches the slipstream and bursts apart into a glittering, drifting cloud. There is no flash, no bang, just thin strips of blackened paper, each one backed with aluminium, tumbling slowly through 20,000 feet of freezing night air. To the naked eye, it is almost nothing. Litter, confetti, the sort of thing a child might throw from a window for the simple pleasure of watching it fall. On the ground, in a concrete bunker outside the city, a German radar operator is about to have the worst night of his career. His screen, which moments ago showed a manageable handful of incoming aircraft, begins to fill with light. Then more light. Within minutes, the display is a blizzard of false echoes, hundreds upon hundreds of them, each one looking exactly like a bomber. He cannot tell which of them are real. Neither can the men operating the master searchlights who begin sweeping the sky at random, chasing ghosts. Neither can the anti-aircraft gun crews whose radar-directed weapons start firing into empty darkness. Somewhere above the chaos, 791 actual Lancasters and Halifaxes continue on their course towards the city, almost entirely unmolested, dropping a payload that will, over the following week, kill more people in a single bombing campaign than any other in European history. Only 12 bombers are lost that first night, a casualty rate so low that some aircrew can barely believe it. The thing falling through the sky that night cost almost nothing to produce. It had no engine, no explosive charge, no moving parts whatsoever. It was, at its absolute core, scrap aluminium glued to paper, cut to a very particular length, and it had just rendered the entire German air defense network of one of the most heavily protected cities in Europe effectively blind. The code name given to it by the boffins at Britain's telecommunications research establishment was deceptively mundane. Window. The Americans would later call it Chaff. Whatever the name, it represented one of the strangest paradoxes of the Second World War, a piece of technology so simple that a schoolchild could understand how to make it, yet so effective that its existence was kept locked away for more than a year out of fear of what would happen the moment the enemy worked out the trick. This is the story of how a few thousand strips of foil made an air force disappear, and why the people who invented it were terrified to ever use it at all. To understand why window mattered so much, you first have to understand the problem that radar had created for Bomber Command, because in the early years of the war, radar was not just a tool for the Royal Air Force. It was also Britain's mortal enemy. By 1940, German engineers had built an extensive web of ground-based radar stations stretching along the coastlines of occupied Europe, feeding data to night fighter controllers who could vector their aircraft towards incoming British bombers with frightening precision. The system relied chiefly on two devices, the Freya radar for long-range early warning and the Würzburg radar for close-range gun-laying and fighter direction, and together they formed what became known to the British as the Kammhuber Line, a continuous belt of overlapping radar coverage running the length of the German-occupied coast. For Bomber Command, flying nightly into this web, the consequences were brutal. Loss rates on raids into Germany frequently climbed above 5%, and on the worst nights considerably higher than that. Across an extended bombing campaign, a loss rate of even 4 or 5% per sortie meant that a crew's statistical chance of surviving a full 30-operation tour was, by some calculations, worse than a coin toss. Aircrew openly joked, with the particular dark humor of men who flew into mortal danger every few nights, that the average lifespan of a new crew could be measured in single-digit missions. The Pathfinder navigator who flew his 30th and final operation was, for long stretches of the war, something of a rarity to be celebrated rather than an expectation. Existing countermeasures were limited and largely reactive. Britain had developed radio jamming systems to interfere with German fighter control frequencies, and intelligence officers worked tirelessly to catalog and disrupt the Kammhuber line piece by piece. But these were measures that chipped away at the edges of the problem. They did nothing to address the fundamental issue, which was that German radar could see British bombers coming from many miles out, track them with precision, and feed that information directly into the guns and fighters waiting to kill them. What was needed was not a way to hide the bombers. Given the size of a four-engined heavy bomber and the limits of 1940s camouflage, that was simply not achievable. What was needed was a way to make the radar itself lie, to flood it with so much false information that the truth became indistinguishable from noise. The maddening part, for the scientists who eventually solved this problem, was that the theoretical answer had been sitting in plain view since before the war had even started. As early as 1937, a researcher working alongside radar pioneer Robert Watson Watt had floated the idea that lengths of wire dropped from balloons or parachutes might overwhelm a radar receiver with false echoes. R.V. Jones, Britain's brilliant scientific intelligence officer, had separately suggested that pieces of metal foil falling through the air might achieve the same effect. The principle was almost embarrassingly simple. Radar works by sending out a pulse of radio energy and listening for the echo that bounces back from a solid object. A piece of metal cut to roughly half the wavelength of that radar signal will resonate and throw back an echo of its own, indistinguishable on a screen from the echo of an aircraft. Drop enough of them, and you do not need to hide your bombers from the radar. You simply give the radar thousands of other things to look at instead. The challenge was an engineer named Joan Currens to solve, and she set about it with the methodical patience of a working physicist. At the telecommunications research establishment, first at Swanage and later at Malvern, Curran investigated the idea in early 1942 and devised a scheme for dumping packets of aluminium strips from aircraft to generate a deliberate cloud of false echoes. She experimented relentlessly, trying wires, trying solid metal sheets, even trying full-size leaflets that could double as propaganda drops, before settling on strips of tinfoil between 1 and 2 centimeters wide and around 25 centimeters long, light enough to be scattered easily from a bomber and yet precisely tuned to disrupt the German radar's particular wavelength. The final, most effective design used strips of black paper backed with aluminium foil, cut to exactly 27 by 2 centimeters and packed into bundles weighing roughly half a kilogram each, around 1 pound. Picture a deck of playing cards, but made of foil-backed paper, and you have a reasonable sense of a single bundle's bulk and weight. It was the head of the establishment, A.P. Rowe, who gave the device its deliberately bland code name: Window. Not a missile, not a weapon, not a device. Just a window, as if to suggest nothing more dramatic than letting a bit of light, or in this case static, into a room. The manufacturing process, once perfected, was almost laughably low-tech compared to the precision engineering going into Lancaster engines or bomb sites elsewhere in Britain's war industry. It required rolling out aluminium foil, backing it onto paper for strength and weight control, and cutting it on guillotines to an exact, repeatable length, a length that had to correspond closely to the wavelength of the specific German radar the bundle was intended to defeat. Get the cut wrong by even a few centimeters, and the strips would fail to resonate properly, drifting down through the night sky as nothing more than expensive litter. Crucially, British intelligence already had a very good idea of exactly what those wavelengths were, thanks to one of the most audacious raids of the early war. In February 1942, commandos had stormed a German radar station at Bruneval on the French coast during Operation Biting, and brought home, more or less intact, a complete Würzburg radar set for British scientists to take apart. Examination of that captured equipment, along with further reconnaissance, revealed to the British that German radar systems operated within no more than 3 major frequency ranges, which meant that with the right length of foil, Window could be tuned to jam virtually all of them. The dimensions were not guesswork. They were the product of captured hardware, painstaking trials, and a physicist who had simply refused to stop testing variations until she found the one that worked best. Once approved for mass production, factories across Britain turned out millions of these strips, cut, bundled, and boxed for delivery to bomber stations, though the exact production figures from the period remained difficult to pin down with precision, scattered as they are across now declassified but incomplete wartime records. If you are finding this interesting, a quick subscribe helps more than you know. The frustrating, almost absurd truth about Window is that it sat ready and tested for more than a year before a single bundle was ever dropped over enemy territory. And the reason for that delay reveals just how seriously Britain's strategists took the danger of their own invention. The scientists working on Window were not naive. They understood immediately that the principle worked in both directions. If British bombers could blind German radar with foil, then German bombers could just as easily blind British radar and return to the night skies over London with renewed impunity, at a moment when the Blitz, though diminished, was still a recent and painful memory. Professor Frederick Lindemann, Churchill's chief scientific advisor, warned bluntly that if the RAF used the technique against Germany, the Luftwaffe would swiftly copy it and could launch a fresh blitz of its own. That warning was enough to see Window effectively suppressed by RAF Fighter Command and Anti-Aircraft Command for well over a year, on the calculation that Britain, at that stage of the war, had considerably more to lose from the device than to gain. It took the deteriorating position of the Luftwaffe and the relentless lobbying of one famously stubborn officer to change that calculation. Air Marshal Arthur Harris, head of Bomber Command, wanted Window released for operational use and made his case repeatedly through 1942 and into 1943. By the spring of that year, he was able to argue persuasively that the bulk of the Luftwaffe's bomber force was now committed to the Eastern Front against the Soviet Union, that raids on Britain itself had become comparatively rare, and that far more RAF bombers were now flying towards Germany than had been the case only a year before. There was also a quieter reassurance circulating among Fighter Command, a belief that the newest generation of centimetric radar coming into British service would be able to cope with whatever retaliation the Luftwaffe might attempt. On July 15, 1943, with Winston Churchill himself present at the deciding meeting, it was finally agreed that the benefits now outweighed the risks, and Harris was given permission to use Window on an operation of his choosing. He chose Hamburg. What followed over the operation that would become known as Operation Gomorrah has been described many times for the sheer scale of the destruction it inflicted on Germany's second city. Less often discussed is the role that a few thousand strips of foil played in making that destruction possible with such comparatively low cost to the attacking force. 24 crews, drawn from 76 Squadron, were the first trained to deploy Window operationally, briefed to drop a bundle through the flare chute once every minute, timed precisely by stopwatch. The results, in the dry language of the official histories, were spectacular. The radar-guided master searchlights wandered aimlessly across the sky, the anti-aircraft guns fired randomly or not at all, and the German night fighters, their radar screens now swamped with thousands of false echoes, utterly failed to locate the bomber stream at all. The human accounts from the German side of that night carry a particular chilling honesty about just how total the confusion was. Radar operators who had spent years tracking incoming raids with practiced confidence found themselves staring at screens that had simply stopped making sense, sweeping for targets that did not exist while real bombers passed by largely unseen. Years later, Albert Speer, Germany's Minister of Armaments, would recall the shock of that first Hamburg raid directly, describing how the new device prevented the anti-aircraft guns from finding the British bombers at all, producing a success that the Allies would go on to repeat with even greater effect on subsequent nights. What is striking is that Window did not need to destroy a single German radar set, jam a single frequency permanently, or shoot down a single night fighter. It achieved everything Bomber Command needed simply by making the operators on the other end of the system doubt their own instruments. It is worth pausing on the numbers because they tell their own story without much need for embellishment. On that first night of Operation Gomorrah, 791 bombers took off and only 12 were lost, a loss rate radically lower than crews had come to expect on raids of comparable scale into heavily defended German airspace. Whatever else can be debated about the ethics and the horror of the bombing campaign that followed, the technical achievement of Window itself, measured purely in terms of British aircrew who came home that night who would otherwise very likely not have, is difficult to dispute. Germany, naturally, did not remain in the dark for long. The principle behind Window was, after all, simple enough that independent discovery was almost inevitable once anyone saw it deployed at scale. German scientists had in fact already identified the same vulnerability in their own research before the Hamburg raid, developing a version they called Duppel, named after the Berlin suburb where early tests had taken place, though it had been held back from operational use for precisely the same reasons the British had held back Window. Nobody wanted to be the side that handed the enemy the idea first. Once the RAF had broken that stalemate over Hamburg, the Luftwaffe wasted little time, deploying Duppel strips of their own, cut to 80 by 1.9 centimeters, during a raid just 6 weeks later, on the night of 7th and 8th October 1943. The German strips were physically larger than the British equivalent, reflecting differences in the wavelengths each side was trying to defeat, but the underlying principle was identical. The comparison with the American effort is, in some ways, even more illuminating, because it shows how a deceptively simple idea can still trip up even capable engineers on points of pure manufacturing detail. Working independently, American astronomer Fred Whipple and U.S. Navy engineer Merwin Bly co-developed their own version of Chaff, with Whipple proposing the concept to the Air Force unit he was attached to. Their early tests, however, failed badly because the foil strips clumped together as they fell, tumbling out of the aircraft in useless lumps rather than dispersing into the wide, effective cloud the principle demanded. It was Bly who eventually solved the problem, designing a cartridge that forced the strips to rub against its walls as they were ejected, building up a static electrostatic charge that caused the individual strips to repel one another and spread apart properly in the air, the same charge ensuring they stayed separated all the way down. It is a small, almost comic detail that one of the most effective electronic countermeasures of the Second World War nearly failed for the Americans, not because the physics was wrong, but because nobody had initially worked out how to stop a few thousand bits of foil from sticking together like static-charged hair. Where Window's legacy becomes genuinely remarkable is not in a single raid, however devastating, but in how long the same basic principle continued to be useful, adapted to entirely different problems. Less than a year after Hamburg, the same strips of foil played a starring role in one of the greatest deceptions of the war. As part of Operation Taxable, in the early hours of 5th and 6th June 1944, Avro Lancasters of 617 Squadron, the celebrated Dambusters, dropped Window in carefully choreographed patterns over the English Channel to synthesize on German radar screens a phantom invasion fleet, sailing towards the Pas de Calais rather than Normandy, helping keep German commanders unsure right up until the last possible moment where the real blow would fall. The same foil that had blinded gun-laying radar over Hamburg was now painting an entirely fictional armada onto enemy screens, a deception that very likely saved lives on the Normandy beaches. Records from the period are not complete, and historians still debate Window's exact contribution against other factors at play in any given raid, from pathfinder marking to simple weather. What is not seriously disputed is the scale of psychological disruption it caused within German air defense circles, nor the speed with which a radar network built over years at enormous cost was rendered substantially less effective by something manufactured in a converted factory using little more than foil, paper, and a guillotine. The man who had pushed hardest for Window's release and the woman who invented it received very different recognition. Harris remains one of the most scrutinized commanders of the war, his reputation forever entangled with the area bombing strategy he championed. Joan Curran's name, by contrast, remained largely unknown outside specialist circles for decades, a quiet irony given the scale of what she had actually achieved. R.V. Jones himself would later declare that, in his opinion, Joan Curran made an even greater contribution to victory in 1945 than her husband Samuel, whose own wartime work on the proximity fuse is far better remembered. It is a measure of how unevenly history apportions credit that the inventor of one of the most consequential countermeasures of the entire air war spent years as a footnote beside her own husband, before recognition caught up with her decades later. What endures from Window's story is not really the foil itself, scraps of which occasionally turn up still in museum collections and the soil of old bomber stations, but the principle it proved beyond doubt: that the most sophisticated technology of an era can be made comprehensively useless not by destroying it, but simply by feeding it too much information to process. Modern chaff, deployed from fast jets and naval vessels facing radar-guided missiles, still works on precisely the logic Joan Curran established sitting in a laboratory at Malvern in 1942, refining strip after strip of foil until she found the length that lied most convincingly to a machine, listening for an echo. Return for a moment to that bomber crew over Hamburg, stopwatch in hand, pushing bundle after bundle of ordinary foil down a flare chute into the freezing dark. They were not dropping a weapon in any conventional sense. They carried no explosive charge, no warhead, nothing that could physically harm a single person on the ground below them. And yet what fell from that aircraft achieved something that months of conventional jamming and electronic countermeasures had failed to achieve outright. It did not merely interfere with the German air defense network, it made that network doubt the evidence of its own eyes. A war fought increasingly on the electromagnetic spectrum, as much as in the skies, had found its strangest weapon yet. A weapon built from substances any household of the period might have recognized, deployed by hand, timed by stopwatch, and effective not because it was advanced but because it was precisely, deliberately simple. Bomber Command did not need to outwit German radar engineers with some superior technology. It needed only to give their radar screen so many ghosts to chase that the real bombers could pass through entirely unseen. The strips fell silently. The radar screamed with phantoms. And for a brief, decisive window in the summer of 1943, an entire city's air defenses simply ceased, in any meaningful sense, to function, undone not by a weapon at all, but by a few thousand pieces of foil, falling like black snow through a German night.